So we have seen this formula which relates the object distance and the image distance. So now what we'll do is we'll look at some example problems where we'll find out the image distance given the object distance and the focal length using the equation. So what was the equation first of all? Well, the equation was 1 by u plus 1 by v is equal to 1 by f. So let's say in this particular problem the focal length is given. Okay, so the focus or the focal length is, let's say, some 10 centimeters, and the object distance is equal to, let's say, some 15 centimeters. Okay, so what we are given is we are given the focal length, we are given the object distance, and let's say it's also mentioned that it is concave mirror. Alright, so what is the question here? Well, there is an object at a distance of 15 centimeters from the concave mirror, and the focal length of the concave mirror is 10 centimeters. We need to find out what is the image distance. Okay, so what I'm going to do, so we have this formula 1 by v, 1 by u plus 1 by v is equals to 1 by f. Let's see what are all the known quantities that we have. So what about u? U is the object distance with the sign convention. Well, object distance is given as 15, but we need to know whether it should be plus 15 or minus 15. Okay, so what was the sign convention? Well, the sign convention says that if you travel in the direction of the incident ray, then it will be a positive direction. Well, how is the incident ray here? The incident ray is like this, right, in that direction, and therefore this would be positive direction. What about this one? Well, if that is positive, this would be negative. Okay, so this is the pole. Now the object is lying on the negative side of the pole, right? So therefore, the object distance will be negative 15. So u is minus 15. What about f? Now f is the focal length. Then where is the focus? Well, focus is here. And on which side is the focus? It is on the negative side of the pole. Therefore, well, focus will be, with sign convention, it will become minus 10 centimeter. Now, if you want to find out the image distance, you would simply apply the formula 1 by v. 1 by u plus 1 by v is 1 by f. So that implies 1 by u, so 1 by minus 15 plus 1 by v is equal to 1 by minus 10. So now we can simplify this. So I can say 1 by v is equal to 1 by 15 minus 1 by 1. Okay, so what would be this one? Well, I can take an LCM of 30 and write it as 2 minus 3. Alright, so that implies 1 by v is equal to minus 1 by 30, or v is equal to minus 30 centimeters. Now what does this mean? Well, first of all, the image distance is 30 centimeters. Okay, with the sign convention it is minus 30 centimeters. Now what this means is the image has to be formed on the negative side of the pole, right? Because the image distance turned out to be minus 30 centimeters. The image has to be formed on the negative side of the pole. Okay, so I will draw an image on the negative side of the pole and at a distance of 30 centimeters from the pole. Okay, now, well, there are two ways in which you can do it, right? You can draw an image like this, such that the image distance here is 30 centimeters, or you can also draw it like this. Okay, now we know already that whenever the object is between the center of curvature and the focus, right? In this case, the object is between the focus and the center of curvature, right? The object distance is given as 15, and we know that the focal length is 10, so this would be 10 centimeters. Now that is 10 centimeters. The center of curvature will be at a distance of twice of 10 centimeters, which is 20 centimeters from the pole. So therefore, when I say the object distance is 15 centimeters, well, we can see that the object is somewhere between C and F. And when the object is between C and F, in case of a concave mirror, we know that the image will be formed behind the center of curvature, and the image will also be inverted. So therefore, I will choose the image which is inverted. So later on, we'll also look at a method in which we can mathematically figure out whether the image is inverted or erect. So in this case, I found out what is the image distance using the equation, but to find out whether the image is inverted or straight, I'm using the knowledge that I already know. Right? I know that whenever the object is between the center of curvature and the focus of the concave mirror, the image will be inverted. Right? From that information, I'm drawing the image inverted. All right. So therefore, the image distance is minus 13 centimeters. So this is how we can use this equation. Now let's look at something called as magnification. Right? What is magnification? Well, it is nothing but the ratio of size of the image to the size of the object. For example, if let's say the magnification is very large, well, what it means is the size of the image will be very large compared to the size of the object. Similarly, if the magnification is very small, what does it mean? Well, it means that the image formed is very small compared to the size of the object. Right? So magnification will basically relate the size of the object and the size of the image. Okay. So let me write it here. Magnification is the size of the image by size of the object. Alright, so in this particular case, right here we have a concave mirror and we'll try to find out what would be this magnification. So we have the object, let's say that is point A, head of the object or the tip of the object, and B is the bottommost point of the object, and as usual we are placing it perpendicular to the principal axis. Now to construct the image, well, I'm going to take this ray of light which is going to hit the pole there. And when it hits the pole there, it's going to reflect back such that the angle of incidence is equal to the angle of reflection. So that is one ray. What is the other ray? Well, I'll take this ray which goes through the center of curvature. Okay. So I know that these two reflected rays are meeting at that point, so that's where the image will be. Okay. So let me draw the image like this. The image will also be perpendicular to the principal axis. And let's say this is A dash, which is the image of A, and this is B dash, which is the image of B. So now we want to find out what is the ratio of size of the image to the size of the object. Again, we're going to use similar triangles. So this is pole P. Now, can you see any similar triangles here? Right? Triangles which involve the image and the object. Well, yes, we can. And if you look at triangle ABP, right, and triangle A dash B dash P, I say they both are similar. Why is that so? Well, first of all, they both are right angle triangles, right? Because the object and the image are perpendicular to the principal axis. Both these triangles, there is a 90 degrees, right? So these are right angle triangles. So both of them have 90 degrees. And if you look at this angle, which is in triangle ABP, and this angle, which is in triangle A dash B dash P, both are same, isn't it? Because one is the angle of incidence and the other is the angle of reflection. So this is theta, this would also be theta. Okay, like this. So in that triangle, two of their angles are same. In that case, the third angle should also be the same because the sum of the angles must be equal to 180 degrees. So if two angles of the triangles are matching, then the third angle should automatically match. Okay, so therefore, these two triangles, triangle ABP and triangle A dash B dash P, they are similar. Okay, so let's say this angle in triangle ABP is beta. In that case, this angle would also be beta. Okay, now we'll take the ratio of sides, right? We know that the ratio of sides in the case of similar triangles must be the same. Okay, now what I'm going to do is I'm going to take the angle theta. All right, see what are the opposite sides of this angle theta in these two triangles. Well, in triangle ABP, right, it is the side AB that is opposite to angle theta. And triangle A dash B dash P, it is the side which is A dash B dash that is opposite to theta. Well, this must be equal to the ratio of sides, right, which are opposite to the angle beta. Now in triangle ABP, what is that side which is opposite to beta? Well, that is nothing but BP. Okay, and in triangle A dash B dash P, what is that side which is opposite to beta? Well, it is B dash. Okay, now what is AB by A dash B dash? Well, AB. is nothing but the object height, right? And a dash b dash is nothing but the image height, and that is equal to bb. What is bb? Well, it is nothing but the object distance. So let's say object distance is some do, right? So bp is nothing but do and divided by the image distance. So what is the image distance? Image distance is nothing but b dash p. Okay, right? So object height by image height is nothing but do by dA, the object distance divided by the image distance. Okay, so now we're going to do something, right? What is that? Well, when we said magnification, we said size of the image by size of the object. So when we say size of the object, we are actually including the orientation of it. Right? For example, when we say size of the object is 5 plus 5, what that plus means is that the object is standing straight, right? It is pointing upwards. Now, if I say the size of the object is minus 5, what does that mean? Well, what it means is the object is inverted. It is pointing downwards. So whenever I say size of the object, right over here, I mentioned size of the object and size of the image. So those sizes will include, right, how the object or the image are oriented. Okay. Now in this case, we got object height and image height, but we haven't really got the object size and image size. Okay. So what we're going to do is we're going to convert this height, right, object height by image height into object size by image size. Now to do that, we need to modify this equation a little bit, right? So I say object size by image size, right? That is equal to, well, if you look at the object size over here, right, how is it? It is pointing in the upward direction. So it will be plus something. Okay. And in this case, if I see the image, well, it is pointing downwards. So its size will be minus something. Okay. So the object size by image size, if you divide the object size by image size, we should be getting some negative number. Right? Because object size is, for example, just for the sake of example, let's take it as plus 10 centimeters. And in this case, image is inverted. So the image size will be some minus 5 centimeters, let's say. Okay, the object height is some plus 10 centimeters and the image height or image size is some minus 5 centimeters. Now if you divide both of them, let object size by image size, you'll be getting 10 by minus 5, which is minus 2. You should be getting a negative value. Alright, so magnitude wise, we know that object size by image size will be distance of the object by distance of the image. But now we need to account for the sign as well. Right? We need to account for that minus sign that we get when we say size of the object by size of the image. Okay, so therefore, what I'll do is object size by image size is not just do by di. Why? Because if you do do by di, you're gonna get what is do? Well, it is a distance from the object to the mirror. And what is di? Well, di is the distance between the image and the mirror. Both of them will be positive quantities. Right? Whenever I say do di, I'm not including the sign, isn't it? I'm not following the sign convention. I'll follow sign convention when I say u and v. But here I'm just writing do and di, distance of object and the distance of image from the mirror. So the ratio of both of them will be a positive number. But I know that in this case, object size and image size, the ratio of them has to be negative because object is having plus 10 as its size and image is having minus 5 as its height. So the ratio should be a negative number. Therefore, I'm going to place a negative sign here. Right? So what I'm going to do is I'm going to write it as image size by object size is equal to, it will be minus of di by do. Right? I've just flipped the numerator and the denominator on both sides. Okay. Now this di and do are object and image distances, right? Without sign convention, isn't it? Do is simply the distance between the object and the pole, and di is simply distance between the image and the pole, right? Without including sign convention. But again, I don't like this formula. Why? Because I want to express this formula in terms of quantities with sign convention. Okay. So what is with sign convention, what would be the object distance? Right, object distance u in this case will be plus do or minus do. What would it be? Well, in this case, if you look at this direction, right, that is the direction in which the incident rays are traveling. So that will be positive, and this direction will be negative. Okay, so u, which is the object distance, well, in this case, the object is on the negative side of the pole, so it will be minus of the gap between the object and the mirror, right? So that implies do is minus u, and the case of image, well, where is image found? Again, image is found on the negative side of the pole. So image distance v with sign convention will be minus of di. That implies di is minus. So what I'm going to do now? Well, in the place of di, I'm going to place minus v. In the place of do, I'm going to place minus u. That gives me minus d by. Okay. So image size by object size is nothing but minus v by u, and image size by object size is called as magnification. Okay, so magnification is going to tell you the ratio of the image size and the object size. Now that magnification will also tell you whether the image is erect or inverted. If magnification is negative, for example, if magnification turns out to be negative, what does that mean? It simply means that the sign of image size and the sign of object size are different, right? If magnification is negative, magnification is, let's say, minus 2. What it means is the size of the image, magnitude wise, is twice the size of the object, right? When I say magnification is minus 2, well, minus 2 is nothing but size of the image divided by size of the object. So when the magnification is minus 2, right, the ratio of the magnitude of size of the image and the size of the object must be 2, which means the image must be double the size of the object. Okay, and what is that minus saying here? Well, that minus is saying that if the object is erect, the image will be inverted, right? The image will be inverted. That's what that minus sign says. Okay, so therefore, in the end, let me just write it down. Magnification, which is represented by capital M, is equal to, in the case of concave mirror, minus V by. Okay, so that is the formula that we need to remember. And even if you look at a convex mirror, the formula of magnification will be the same. Right? We're not going to derive it here, but if you derive it, you will get it as minus V by U. So now what we'll do is we'll look at some problems. We'll try to understand what this magnification is by looking at some examples.